Hello, this is Gary Marr of Glendale Community College. This screencast is for my CIS 156 Python 1 students. In this lesson, we're going to talk about Chapter 10, which is the Introduction to Custom Classes and Object-Oriented Programming with Python. We've been using class objects for quite a while in the textbook, back to strings, lists, etc. The dot notation that I referred to in a previous lecture is really what we're going to implement on our own now. What I've done is I've taken one of the exercises, the very first one, and I've added some comments to it. I've actually added a little bit of code to it just to hopefully drive home the point of what class objects do for your programs. For starters, let's talk about class objects a little bit. Class objects were developed initially for object-oriented programming to make code more reusable. Developing software, if you haven't already found out, is a very labor-intensive activity, and time is money for most companies. So whenever we can use someone else's code, that's an advantage. Code reuse is synonymous with object-oriented programming, because what we're going to do now is we're going to take certain things and make them class objects and then instantiate those class objects inside our application. For this particular example, they have a class object called a pet, and they're going to use that pet in another application I've written called exercise 10-1. This is in your textbook. Now I've added some additional comments. I've added actually some additional code to illustrate some points, but I still think it'll follow fairly closely to what Gaddis has in his textbook. You want to first off think of as a class object as a thing, a noun if you will. That noun contains not only data, but also verbs, adverbs, and adjectives which help describe the data. So in this particular example, I have a class called a pet, which is typically a noun. Other class objects might be customer, vendor, product, bank account, checking account, things. Those things contain data, which is identified here with some instance variables. Okay, I can tell they're instance variables by the self keyword. Whenever you see this self in the beginning of a name, self dot, again dot notation, that's referring to this particular variable here as being a member of that class object, like animal type and like age. Also in this class is a series of methods. Now methods are no more than functions, as evidenced by the def keyword, except when they're owned by the class, we're not going to call them functions, we're going to call them methods. These methods accept parameters, like name. They also have the self keyword, and that's a requirement. It's one of those Pythonisms, which basically says if you're going to create a method in a class, you have to first identify self to identify that function to be a method of the class, and then any parameters you're going to pass it. This one has one parameter, but this one up here actually has 3 parameters. The methods you're going to find here are underscore underscore init, which is essentially a constructor. Now, for those of you familiar with other object-oriented programming languages, a constructor is a method which is called when the object is instantiated. So in my application that I've got here called exercise 10-1, when I first instantiate a image or instance of pet, it's going to look for this constructor method and run it automatically. Typically what it does is it initializes key variables inside the object itself. This object has a variable called underscore underscore name, underscore underscore animal, underscore underscore age. These variables are object variables, and they're actually updated in this method call up here, this constructor. And you're going to find when we get to the actual instantiation of pet, it's going to pass it three pieces of information. The pet's name, animal type, and age. That's going to be stored in the instance variables of this class object and represent the data of this particular object. Below it, you're going to see a series of methods. Some are going to be called set. Some are going to be called get. This is basically what reinforces something that's available with object-oriented programming called encapsulation or data hiding. What's happened here is that we're going to make all of our instance variables, name, animal, and age, we're going to indicate those with a double underscore, which makes them private. That means the only Python statements which can change these variables, okay, are within this class. If it doesn't have an underscore in front of it, it's a public member. So what I'm doing is creating a public interface through sets and gets, but private data through these private instance variables. So I can call set name, set animal, set age, get name, get animal, get age from outside of this file, But the only thing that can update my underscore underscore name, underscore underscore animal type, underscore underscore age are statements from within this file. Okay, more about this in a minute. There's two kind of methods here. Mutator methods, or setters, and accessor methods, or getters. The setters allow me to change instance variables. The getters allow me to return instance variables. Okay, this is a very typical class file that you would see out there for any number of things. It's typically separate from the application, and what this does is it enforces reusability. If this was a pet store, this particular class could literally be used by 50 or 60 different applications. That's the code reuse part, where they would simply include this code or import it when they started the application. One application might be to keep track of the dog's health or the pet's health. Another application might be the bill of sale. Another application might be the accounts receivable document to pay the person or to get payment from the customer. The accounts payable might be to pay the breeder. But they all would use the class called pet because this information is so generic and so common to pets, it can be reused. Now, let's turn to the application. The application is going to first import pet, which make this code in this file available to this particular application. So I'm going to get all of the class file and all of its members. Instance variables, instance methods, and any class methods, but there are no class members for this example. It's got a module called main, which is the main module. The first line of the program is down here, and it starts the process by calling main. Main has no parameters. It sets some local variables. It asks for the name of the pet, the type of the animal, and the age of the pet. All standard vanilla Python stuff. This is where it gets a little bit dicey. On this first call, it says, I'm going to create a variable for this program called myPet. It's going to equal pet, which is the import, dot pet, which is the name of the class, and I'm going to pass it the name, the type, and the age, which I just collected. If I go to back to pet, this is the constructor, which I labeled here, and you can see it's going to accept name, animal, and type. Now, the way this works is when the class is instantiated, in other words, when it's equated to a variable, it looks for the init method or the constructor right here. It passes the information, which basically initiates this instance of myPet. So myPet now has data in it called, whatever we put the name, the pet type, the age. Now what I did is I created a second instance of pet, because you could have multiple instances of a class. Just think about it. If you had a student application that had 500 students, you'd have 500 instances of student, each with a different name. My second instance called pet2. In this one, I simply supply the constructor with variables, Fido, dog, and 10. So instead of using the variables that were input up here, I'm just simply plugging it with string literals. So again, if I go back here in this instance, it looks again for init, and it puts Fido, dog, and 10. So the second instance has the name, animal, type, and age, different than the first one. The data is different, but all the methods are still sitting out there as the same. You can think of those methods as helper functions, if you will. All right, let's go a little farther. And the next part of this process is going to call a series of gets. It's going to get from the instance myPet the name, the animal type, the age, and then it's going to get from the second instance the name, the type, and the age. So when I run this application, and again, I would run the exercise, not the class. The class, if you try to run it, nothing will happen. It's got no executable statements. Everything is inside this thing called class. Class is in the first position, and everything else falls underneath it. Now, it is possible, in a lot of examples, where you'll see inside the application, above the first statement, instead of an import, you'll actually see the class defined. That's fine. But importing pet into as a class is a much more reusable option. Okay? So let's run this guy from here. It's going to ask me for a pet. We're going to use a pet name called Daisy. We're going to call it a dog. And we're going to make it 8 years old. And then if I slide this up a little bit here, so you can see everything, you can see that first instance of Daisy 8, or dog and 8. But I'm also, let me slide this back down again, I'm also printing out the information from the second instance. So as the first instance had Daisy, dog, and 8, the second instance had Fido, dog in 10. Okay. Now, the one thing this is not doing is it's not doing any sets. So, for example, if I did this, set, oops, we type set underscore name, and then I supply, oops, I'm sorry, I forgot the actual dot notation. Let's call this my pet dot set name, and in the set name I supply a new name like Leo, close quote, close parentheses. Whoops, I gotta get a quote in there. What this would do is would come down here, print this information out. It would now set the instance of pet's data member from what we keyed initially, Daisy, to now a new value of Leo. And what I'll also do here is let's put in the print statement below it, so we can see cause and effect here. So, and here we go. All right. Let's save it and run it again. I'm going to push this up a little bit so we can see better. Whoops, something happened here. What did I do? Looks like unspecified indent. So let's see here. Oops. Extra space in there, it looks like. Let's try it again now. I had an extra space there. Okay. Name of pet is Daisy. And its DOG is the type of pet. 8 years is the age. It continues down to fill in the rest of the stuff. Whoops, I got one more problem here. I've got to fix an error in the call to set. So let me just go back up here. My pet, and you guys might be able to see it already. The problem is I used camel casing, and the example from the book did not. So let me save this. 3 times the charm, they say. Let's run it one more time. Daisy. Hopefully this illustrates the fact that even though I've been programming for probably 40 years, I still make mistakes. So here we go. The first time it's Daisy, like what we keyed on the input, keyed on for the input. And then of course I've got Fido next. But then I changed Leo with my accessor method. I changed it from Daisy to Leo, sorry. I changed the instance of my pet. And here you can see this set working. So what you're going to find with most object-oriented programs, whether it's Python, C#, Java, Visual Basic, is you're going to see the class. You're going to see data defined as private variables, only accessible from the class itself, and then public, gets, and sets, and other methods which are helper methods. Okay? Let me go back over here for 1 second to show you something else. So again, if I go back to my class pet, these double underscores in front of these names, these are all what would be considered private variables. The fact that they have self in front of them, which they need to have, means they belong to the class object. So when I do a set, I said set name Leo. It set Leo to name. Name equated back into that instance variable. So I use the public interface to update the private instance data. Now I'm sure we'll have some more examples, and I'm sure you're going to have lots of questions, but as I tell my 150AB class, the fundamentals of object-oriented programming, using objects is all about code reuse. There's no sense reinventing the wheel. Why should we ask a bunch of programmers all to create their own version of pet when we can create one and then include it in our code with an import statement? That's the whole basis for creating custom classes. There are many built-in classes that you've used since day one. String, integer, float are all class objects you've used since day one. They all have helper methods to assist you in the formatting or casting of that data. If you've got any questions, let me know. This is a little bit more complicated, but if you think about it, it may be a little simpler in the long run. Thank you.